Hello everyone, welcome to another section of differential and integral calculus. Okay, now I'm having 10 questions on the board. I would like you guys as a Jambites to know how to solve. Okay, so if you're writing the 2024 UTME, you should know how to solve these 10 problems on the board. On the left hand side you have 5 differential, and on the right hand side we have 5 integral. Okay, now I'm going to use the possible method, okay, for solving these guys, that to make the question the easiest. So in other words, I'm going to solve these questions using the fastest method you ever come across, okay, for this 2024 UTME. Now do not forget to share and like this video if you actually gain something or you learn something. Okay, the name of the YouTube channel remains Dr. Flash. You can find almost all science videos, including chemistry, mathematics, and physics. So I would like you to subscribe, click on your notification bell so you get more notifications when a new video is uploaded. Okay, now the first question here is 2x plus 5 whole squared x minus 4. That's the first question. Now, seeing this question, the first thing that will come to your mind is to start expanding as a UTME student. Now when you start expanding, 2x plus 5 all squared, you expand and then multiply by x minus 4, of which, you know, after expanding this guy, we're going to get three different sets of numbers, one having squared, one having x, and then we have a constant. Okay, so by expanding this guy we get a trinomial, and then multiplying by this guy will make it longer. Okay, so that's a little bit stressful, and as a Jambite, I do not advise you to do that inside an examination hall. Of course, there is a shortcut for doing this. Now, what is that? I'm going to start with the solution here. Okay, so for this guy, we are having 2x plus 5 all squared x minus 4. I'm going to write it on the board. So we have 2x plus 5 all squared x minus 4. Okay, now how are we going to solve this guy? First of all, let me equate it to y, such that when we find the derivative of y, we say that we have found the derivative of this particular expression. Okay, now differentiating y with respect to x, we could either say y prime, of which is not compulsory since you are not to show any working in the examination hall. We could either say y prime or dy over dx. Now whenever you see two brackets or two expressions being multiplied by each other, okay, two brackets or two expressions being multiplied by each other, and both of them are having x, what should come to your mind is product 2 in differentiation. Is among the basic techniques that you should have known before now as a student under calculus. Okay, so we are going to have what now? Product 2. But seeing this one again, we could also have another product 2 here, or we could make use of the chain rule for solving this guy. Okay, so what I'm going to do, I'm going to evolve the product 2 and the chain rule for this particular question rather than just using only the product 2. Okay, so now for the product 2, of course there's a formula for it, but you do not need to cram that formula. Okay, all you just have to do is learn the techniques for doing this without any formula. Now what I'm going to do, the first bracket here, which is 2x plus 5 all squared, I'm going to write it down, 2x plus 5 all squared, and then I'm going to differentiate the other bracket. So if I cover this first one, I'm going to write it down, and then I'm going to differentiate this next one. So now differentiating x minus 4, when you differentiate minus 4 you get 0, which is a constant, and then when you differentiate x to get 1, so I'm multiplying by 1. It's as easy as that. Plus, now we're going to write the next bracket, which is x minus 4. Okay, now differentiating the first bracket, we're going to make use of chain rule because of the power outside. Whenever the power is greater than 1, we'll make use of what now? Chain rule, not just product 2. Okay, so now to make use of chain rule, first of all, we're going to differentiate what is inside of the box. Okay, inside of the bracket, we're having 2x plus 5. When you differentiate 5, you get 0. When you differentiate 2x, you get what now? 2. So I'm going to multiply by what? By 2. But we are not done. Next thing, there is a 2 outside of it. Remember, when you are differentiating, if y is equal to x is to the power n, okay, or let's say a is to the power n, where there is a number beside x, which could be 1 or above or even below, then y prime, which is the derivative, will be equal to an x to the power n minus 1. So I'm multiplying the number beside x by the power of x. So I'm going to do the same thing, multiply by the power of this bracket, that is the 2 here. Okay, and then we're going to subtract 1 and fill in the initial bracket. We're going to have 2x plus 5 all raised to power 2 minus 1 gives you what now? 1, as easy as that. So for me, we simplify, we're done with differentiating. So dy over dx will now be equal to, this bracket gives us 2x plus 5 all squared plus, I can choose to expand with whichever bracket I want, okay? So I'm going to get 2x minus 4, 2x plus 5. Now, even before expanding, I can see that I can actually factorize that 2x plus 5, which is common on both sides. So if I do that, I'm going to get 2x plus 5, okay? And what will be left there? 2x plus 5, okay? Now what will be left there? Plus 3 into brackets x minus 4, of which we can now expand this guy. And that will be giving us 2x plus 5 into brackets 2x plus 5 plus, open the brackets, 2x minus 8, okay? Now let's simplify further. By doing that, we get 2x plus 5 multiplying. Now 2x plus 2x will give us, that's 4x, okay? Now 5 minus 8 gives us minus 3. Now you probably find this in the option, okay? In most jam pass questions, you won't find this guy expanding in the option. So it's advisable to leave it this way, okay? If it is, if you find this in the option, then you should stop here, okay? Make sure as you're solving, you're looking at the option. So basically, this is a very easy step to take, okay? For solving a question using product rule and quotient rule in one, okay? Jam will not ask you to use product rule and quotient rule. They won't even tell you the method to use. They're just going to give you the question and they expect you to know the easiest way as a student to find your way into the answer. Okay? Now, the next question we're having here, number 2, is x squared minus 1 over x all squared. Okay? Now, how are we going to solve this? I'm going to take off these parts and solve that. Okay? So we're having y is equal to x squared minus 1 over x. Now let's differentiate this. To differentiate this, first of all, differentiating y gives you dy over dx equals, now this one is quite easy. Okay, there's a square there. Okay, this one is quite easy. We are just going to apply only chain rule. You can choose to apply product rule actually, that is by bringing another bracket and getting rid of the square. But I think chain rule will actually be an easy method of solving this question. So what you might want to do first of all is differentiate whatever is inside of the brackets. And to differentiate what is inside of the brackets, remember there is a 1 over x here, so you should know how to differentiate that. Now differentiating x squared, you get 2x minus, when you differentiate 1 over x, what are you going to get? You are going to get minus 1 over x squared. Of course, there's a shortcut to doing that. Whenever you are having the x in the denominator, when you differentiate it, just put minus above and then increase the power by 1. Okay, let me show you how it's done. So if you have x to the power of minus 1, differentiating this guy, that will be minus 1 x to the power of minus 1 minus 1. That's minus 1 x to the power of minus 2, which is minus 1 over x squared. So that's a shortcut, okay, for doing that. Now we've succeeded in differentiating inside of the brackets. So this is what we have here. Next, remember what to multiply by the power according to this rule. Multiply by the power. So we're going to multiply by 2, okay, and then write down the brackets, okay? We're going to write down the brackets, okay? By writing down the brackets, initially we're having x squared minus 1 over x, and subtract 1 from the power, so we get 1 as a power. So for me, we're done with differentiating. The next thing I want to do is simplify. So I can bring these two to the front, so have dy over dx equals 2 open brackets 2x minus 1, minus times minus gives you plus, so you have plus 1 over x squared multiplied by x squared minus 1 over x. You probably find this one as the option as well. They might not want you to expand further. So I think this should be an easy way of solving this particular question as well. Okay, so you see these are very, very easy codes to solving these questions. I'm going to take the next one, and the next one is cos theta minus sin theta all squared. So for number 3, we're going to have cos theta minus sin theta all squared. Okay, this is the question. Now for this particular one again, we can solve it using the same method just like we did on this one. Okay, so now let's go. Dy over dx, if this is equal to y, dy over dx becomes, remember, you can multiply with 2, okay? You must multiply with 2 according to that rule. So we're going to have 2. Now differentiate cos theta, we're going to get minus sine theta. You should know how to differentiate trigonometrical functions before now, okay? Minus sine theta. Differentiate sine theta, there's a minus there already. Differentiate sine theta, you get cosine of theta, okay? And then multiplying by the bracket, which is cosine of theta minus sine of theta all squared, okay? Minus 1. Now 2 minus 1 is basically 1, so no need of writing 2 minus 1, so we can just write it there, okay? I'll review it again. 2 multiplies the whole question, then differentiate it cos theta. When you differentiate, you get minus sine theta. Differentiate sine theta, you get cosine theta. This minus is already there, okay? And then you write the question again and subtract 1 from the power. The reason I did not write 1 there is because 2 minus 1 is 1, and anything to the power of 1 is same thing as that particular number or expression. So from here we're going to have 2. Now I can factorize that minus from this question, this first bracket. So we have minus outside, okay? Minus 2 into bracket sine of theta plus cosine of theta, and that will multiply cosine of theta minus sine of theta. You might also want to stop here, but seeing this, I think we can actually simplify this further using some trigonometrical functions. Okay, now sine theta plus cos theta times cos theta minus sine theta. What does that remind you of? That's difference of 2 squared. Now difference of 2 squared is saying if you have x squared, for example, minus y squared is equal to x minus y multiplied by x plus y, okay? So if you're having 2 numbers being added, multiplying by those 2 numbers being subtracted, we can actually pick one of them, square it, and subtract the other one squared from it. So I think we can apply that principle here. Here we're having cos theta plus sin theta, which is the same as sin theta plus cos theta. And here we're having cos theta minus sin theta. So that will be equal to minus 2 into brackets cos squared theta minus sin squared theta. Now saying cos squared theta minus sin squared theta, I think it should remind you of a very useful formula in trigonometry, okay? Now cos squared theta minus sin squared theta. Remember that cos 2 theta, okay, I'm going to write recall that cos 2 theta is equal to 2 cos squared theta minus 1, okay, and also equal to 1 minus 2 sin squared theta, and then it is equal to cos squared theta minus sin squared theta. Okay, so we're having cos 2 theta equals 2 cos squared theta minus 1, or 1 minus 2 sin squared theta, or cos squared theta minus sin squared theta. Okay, so we can replace this expression, which is already here, by cos 2 theta. So this guy upwards is going to give us, we're already having a minus 2 outside, times cos 2 theta. Okay, so our final answer is going to minus 2 cos 2 theta. That's going to be our final answer for this particular question. And then for number 3, we are having sin x minus x cos x, okay? Sin x minus x cos x, that's what we're asked to find. So we're going to do number 4 question up here. We are going to have sin x minus x cos x, okay? So I'm going to say y is equal to sin x minus x cos x. Now this one is quite easy, okay? Sin x minus x cos x. It might be, okay, this should be cos x actually, okay? Now, for sin x, we just differentiate normally. But for x cos x, we can't just differentiate x and cos x. You have to make use of the product rule because we're having 2 things multiplying each other, having x. Remember what I said initially. You can rewind it down to the beginning of the video. So take note of that. Okay? So differentiating y with respect to x, we get dy over dx. Okay? And even for this one, we are differentiating with respect to theta. So if we are having dy over the theta rather, okay? Anything you are differentiating with respect to, okay? Just disregarding this statement. So we're going to get with respect to that question. So dy over dx, differentiating sin x, you get cos x, then minus, okay, into bracket. Let's differentiate this whole expression here. So put down x, remember we're going to cover x, then put it down. Differentiate cos x, so we're going to get minus sin x, multiplying this one, get minus sin x, okay, plus putting this guy down, cos x, differentiating x to get 1, that's times 1, so we can simplify. to get cos x minus, let's open the bracket, to get plus x sine x times this guy, you get minus cosine x, which multiplies 1 to give cosine x. Okay, so we've expanded the bracket. Cos x minus cos x gives you 0, and then we're left with x sine x as our final answer. Okay, so that was pretty easy. And then the last one we're having is 2x over sine x. Okay, so for number 5, we're having 2x over sine x. Okay, let's say y is equal to this one. Now for this particular question, we're having a numerator and a denominator. Now we know that when we divide two numbers, okay, using for example 2 to divide 4, that's 4 over 2. The answer we get is what we call a quotient. Okay, so a quotient is actually that value we get when we divide two numbers. For that reason, we are seeing a numerator and a denominator. We know, of course, if we are to apply any mathematical principle with this, we can't really differentiate. We can only express it in another form, probably like a series or something else. And to differentiate this guy, we'll apply what we call the quotient rule. Okay, now the quotient rule also has a formula, but remember I said in this video we're not going to be making use of any formula. We're just going to learn how to differentiate these things. Okay, I could also write the formula on one side of the board, okay, for you guys to remember, just in case of anything. But then I'm going to solve these questions without making use of any formula. So differentiating with respect to x, we first of all get dy over dx, and that will equal, we're going to write down the bottom. Okay, so the number at the bottom, which is the denominator, we're going to write it down. So we have sine x, and then differentiate what is on top, that's the numerator. So when you differentiate 2x, you get to subtract. Remember, for products we are adding, but for quotient we are what now? Subtracting. And then write what is on top, which is what? 2x. Differentiate what is at the bottom. When you differentiate sine x, you get cosine of x. Okay, and then divided by, when we square, we're going to square the denominator. Okay, so we're going to square the denominator. So sine x all squared will be in the denominator. Sine x all squared. So here is it again. Write down the bottom one. Okay, differentiate the top, multiply, minus, write down the top, 2x, differentiate the bottom, multiply. Okay, divided by the square of the bottom. So we'll have dy over dx will equal, multiplying this, you get 2 sine of x minus 2x cos x divided by sine squared x. Now we could leave it like this, depending on the option. The option is left like this, no problem. But we could also expand this or express this in a different form. Now, 1 over sine x is what we're having here, multiplying this whole expression, which is the same thing as having sine squared in the denominator. Okay, 1 over sine squared is what. Now, if you recall, 1 over sine square x has a formula. Okay, 1 over sine x is equal to, now these are what we call the reciprocal trigonometrical functions. Okay, 1 over sine x is cosec x. Okay, now 1 over cos x is sec of x, and then 1 over tan of x is what we call the cotangent of x. So that's secant, cosecant, and cotangent. Okay, so if I have 1 over sine squared x, it should be what now? Cosec squared x. So I'm multiplying this whole stuff by cosec squared. Therefore, dy over dx will be equal to cosec squared x multiplying 2 sine. Okay, we can just factorize out this 2. So I'm going to factorize this out instead of writing it again. So we have 2 cosec squared x multiplying sine x minus x cosec cosine of x. Okay, so that should be the final answer. Dy over dx gives us 2 cosec squared x times sine x minus x cosine of x. So it's very easy to understand. I hope you guys have been following throughout this video. Okay, and if you have any more questions or something you'd like me to teach, okay, do make sure you put this in the comment section, and it will help me to create more videos, okay, and create awareness for other students that want to learn. Now on the right hand side, we're having 5 integral functions which we are asked to solve. Okay, 5 integral functions, and those integral functions are what I'm going to be treating now. Okay, so I'm going to take off this left hand side of the board. Now, just like differential calculus, on integral calculus, there's also a general formula for solving. Okay, so if y is if you're asked to integrate, for example, ax to the power of n, okay, now the integral of this guy, okay, becomes ax to the power of n plus 1. We're going to add 1 to the power and then divide by the total power. So that's like the reverse, okay? So y is equal to this guy, okay? But remember, we have to integrate to some respect to something, in this case of which is what now, dx. Okay, so that's what we're asked to do. Now, for the first question, we're having x squared minus square root of x over x. Now, how are we going to do this? This is what we're asked to integrate, okay, with respect to x. Now, to do this, there is no special formula, just like quotient rule. We can't apply quotient rule here. Quotient rule only works for differentiation, okay, does not work for integration. So what I want to do is first of all to split this guy. So by splitting it, I'm going to get x squared over x, that's x, minus x to the power, this 1 over 2 over x, okay, the x. So I'm going to have x minus, if I can simplify this guy, x to the power 1 over 2 over x, that should give me x to the power of 1 over 2 minus 1, which is power of x in the bottom, that's minus 1 over 2 dx. So when I integrate this guy, integrating x, I'm going to get x to the power 1 plus 1 over 1 plus 1, okay, minus x to the power, add 1 to the power, that's minus 1 over 2 plus 1 over minus 1 over 2 plus 1. So I'm going to get x squared over 2 minus x to the power 1 minus 1 over 2, that's 1 over 2 over 1 minus 1 over 2, that's 1 over 2. So that simplifies to x squared over 2. 2 goes to the top, okay, when you simplify this, minus 2x to the power 1 over 2, which we can actually write as x squared over 2 minus 2 root x, okay, plus our constant k. Now this k is actually telling us that whenever we differentiate something, of which integral is the reverse of that thing we just differentiated, we get some constant that we don't know, okay, which was probably there and we can't find back, except we are given what we call initial conditions, okay. So I'm going to add that k whenever we integrate. So from this place where we started integrating, there's going to be a plus k. Do not forget to include your plus k or plus c, okay, depending on the domain variable you want to make use of. And the next question we're having here is 2x cubed plus 2x over x, okay, that's what we're asked to do. So 2x cubed plus 2x over x, okay, that's going to give us the integral. We can separate of 2x squared, this one divides this one, plus this one divides this one, plus 2 dx. Okay, so now let's integrate. By integrating this guy, we get 2x, add 1 to the power 3 over 3, plus differentiate this guy and integrate this guy, rather, we're just going to add x to it, so that's 2x, okay, plus c, okay, or plus k. So you see, this one is quite easy. It was very, very straightforward. And number 3 should be even easier. Number 3, you are asked to integrate 6x squared minus 2x plus 1 dx, okay. Now to do that, integrating generally, we're going to have 6x cubed by adding 1 over 3, okay. You don't have to start showing your workings, you can skip step, minus 2x, when you add 1 to the power, you get 2 over 2, okay, plus 1. So we're going to have what now? Plus x, okay, and our constant c. So we can reduce this, guys, we get 2x cubed minus x squared plus x plus c, okay. That's what we're going to get as a final answer. So quite easy. And then for number 4, you are asked to integrate. I'm going to split it directly instead of writing the question again. 1 over x cubed plus x divided by x cubed, that will give you 1 over x squared, okay, dx. Now to integrate this guy, we want to take everything upward first. So we have integral x minus 3 plus x to the power of minus 2 dx. Okay, so by integrating this one, we're going to add 1 to the power. When you add 1 to minus 3, you get minus 2. So you have x to the power of minus 2 over what's the power? That's minus 2 plus x to the power of minus 1 over minus 1 plus c. So that gives you, when you simplify, you get minus 1 over 2x squared minus 1 over x plus c. I'm going to explain this part. Now, minus will always go to the top, okay? You do not leave minus in the denominator. So you have minus 1, x to the power of minus 2 comes down, that's what we're having here, and the 2 is already there. Now, this minus goes up, it affects this plus, so it becomes negative. Okay, now x to the power of minus 1, break it down, it gets 1 over x plus c. So that's very easy. And then the last question we're having there is to integrate this one, okay? Now, this number 5 is a question on definite integral, okay? It's a question on definite integral. Now, the question here has what we call the upper and the lower limits. I'm just going to switch this marker. Okay, so you have minus 1 and then 2 here. Take note that the number on top has to be greater than the number below. Okay, so you have 2x squared plus x dx. This one is quite easy. All you have to do first of all is integrate this one, okay, and then substitute those numbers. I'm going to show you how it is being done. So solution, we're going to have, integrating this guy, we're going to have 2x cubed over 3 plus x squared over 2. I've showed you how to integrate, okay, or you should know that before now. This is what we get, okay. We are going to have these limits, minus 1 and 2. Now, what does this limit tell us? We're going to substitute them, okay. We're going to substitute the first one. The answer we get, we're going to subtract the answer we get by substituting minus 1, okay. So I'm saying when substituting minus 1, you get an answer, you drop it, and then substituting minus 2 rather. So the result you get, you take the difference, okay, so you get your answer. So by doing that, substitute 2, we have 2 into bracket 2 cubed over 3 plus 2 squared over 2, okay, that's the first one, minus, by substituting in minus 1, you have 2 minus 1 all cubed over 3 plus minus 1 all squared over 2, okay, so that's what we're going to get. Now, simplifying this, 2 cubed is 8 times 2, that's 16, so you have 16 over 3 plus 2 squared is 4 over 2, that's 2 minus minus 1 cubed is minus 1 times 2, that's minus 2 over 3 plus minus 1 squared is 1 over 2, okay. So I'm going to take out the parts. Okay, so here we're having 16 over 3 plus 2. Opening the bracket, we get plus 2 over 3 minus 1 over 2. Yeah, and then you might want to simplify this one further. Okay, so LCM of everything here is 6. 3 into 6 is 2 times 16, that's 32. 1 into 6 is 6 times 2, that's 12. 3 into 6, that should give us 2 times 2, that's 4. Minus 2 into 6 gives us 3 times 1, that's 3. So when you do everything here, you do the math. 32 plus 12, that gives us 44. Plus 4, that's 48. Minus 3, that's 45. So you should be having 45 over 6. Okay, you should be having 45 over 6, of which you can reduce to the simplest. Okay, now I advise you to be very careful for questions like this, just so you don't make any mistake. And I'd like us to go through it again to make sure there are actually no mistake, because I just solved everything using without using a calculator. So we're having 2x squared plus x as the question. Integrating, you have 2x cubed over 3 plus x squared over 2 and the upper and lower limits. Okay, that's fine. When the problem comes in is when you're substituting in our limits. Okay, and by substituting in 2, we get 2 here, okay, plus putting in 2 squared, okay, minus putting in this one, we get 2, okay, minus 3, minus 1 is the power of 3, and the 3 is at the bottom, putting in minus 1, okay, that's fine. So 2 is the power of 3, that's 2 times 2, 2 3, which gives us 8 times 2, that's 16 over 3, plus 2 squared is 4, 4 divided by 2, that's 2, so we go back to 2, minus 1 cubed is minus 1 times 2, that's 2, or minus 2, rather, so you have minus 2 over 3, plus minus 1 squared is 1 over 2, okay? So opening the brackets, minus times minus 2 over 3, that's 2 over 3, minus times minus 1 over 2, that's, so you get minus 1 over 2. Now the LCM, of course, 3, 1, 3, 2 is 6. Okay, and then 3 into 6, that's 2 times 16, that's 32. 1 into 6, that's 6 times 2, that's 12. 3 into 6, that's 2 times 2, that's 4. 2 into 6, that's 3. Okay, so we can do the math. 2 plus 12 gives you 44. Plus 4, that's 48. Minus 2, that's 45 over 6. So I think that will be your final answer. Or we can as well reduce that guy to a whole number. So 6 into 45, that should be 7. Okay, that should be 7. What will be left now? 6 into 45, that's 7, right? And what will be left? You can choose to make use of the calculator if you are to write it in decimal. Okay, depending on what you are given. So 45 divided by 6, that's 7.5 in decimal. Okay, 7.5. Okay, or we could as well write it in whole number, which is 7 whole number 1 over 2. Okay, so that's the final answer. So it's as easy as that. For most problems, I would like you guys to take your time to go through it. Okay, and that's after you've solved majority of the questions, so to avoid mistake, because you might know it and at the end you get a lower score, wondering why not knowing you made a few errors. So this is how it is being done. Tricks or shortest course of approach to these various questions. Just take questions on integral calculus and differential calculus. So do well to like, share these videos to your friends writing UTME. Do not learn alone. Okay, and as well, if you have a question or you have a problem with anything we've done, drop it in the comment section and then I'll respond to it as soon as possible. Okay, also don't forget to click on the notification bell after subscribing so you get more videos when they are being uploaded after your UTME and the likes. Okay, see you in the next video. God bless.